All right, this is going to be Algebra 2. We are Unit 3 now. Claire says hi. And then Ben sits there. Yeah, so we're doing 2 lessons today because they're both really short and they're both kind of review. So we're doing lesson 1 and 2. We are on Standard I. If you take a look at our unit guide, we're just doing kind of the intro to quadratics and then intro to factoring quadratics. So this is really like how to FOIL, if you have forgotten. All right, so let's do the question. Oh, do you guys know how to take notes? You're supposed to come up with the question on your own, and then I am supposed to give you the information, and then you do the question after I give you the information. Let's try that, yeah? All right, here's the information. Here's the answer to the question that you still need to ask. All right. Quadratic. And not quadratic. All right, so a quadratic, let me give you some examples here. This would be x squared plus 3x plus 1. Let me give you a not quadratic. X plus 1. Let me give you a quadratic. Negative x squared. Let me give you a not quadratic. X cubed plus x squared minus x plus 3. You think you got it, Claire?
Is it when there's a square? Like you can't have anything above a square, but you need to have one.
Yeah, that's the best way of saying it. So can I repeat that into the microphone? Just going to say what you said. So you can have anything up to a square, but you need to at least have the square. So this one has too much. This one has exactly the right amount. Yeah, and it can be negative, positive, doesn't matter. What was the question you think we were answering here?
What is a quadratic?
Yep, that is it.
Are we supposed to have the little sheet that tells us what standards for everything?
Did I not print it out yet?
You didn't give it to us. You might have printed it out.
I did print it out. I did not give it to you.
So I don't have it stapled in my note. Yeah.
That is my bad.
Oh wait, I did leave a page for it. I subconsciously did that.
I swear I printed others. My bad, guys. Well, I will remember that you guys have this out of order.
No.
No?
We both left a page.
Oh, okay. Yeah. Well, the video is now saying, Arrow, leave a page. I'm sorry. We'll make a note of this before you watch the video. All right, so this is the page that I forgot to hand out. All right. So they're stapling that in there. So that was the answer to the question, what is a quadratic? Question mark. All right. So I'll just make a note here to make it more explicit what Claire said. The highest power is 2. I think that's...
It needs to have a 2.
And it needs to have a 2. So that means the highest power here was a 1. Highest power here was a 3. That's why these were not quadratic. I think this is the best, quickest definition that I can give you. By the way, if you want to know the names of these, I can give them to you. It's not super important, but you should memorize this. Right now, my calculus kiddos are really struggling figuring out, is this a quadratic? What is this? And I'll tell you, this is a linear. These are used in calculus. Please do memorize them. This is going to be a cubic. We'll hit him later in the year. But these are all quadratic. Technically, you can think of this as a polynomial too. Anything can be a polynomial depending on what you're looking at. But a polynomial is the umbrella that a lot of things fall. All right, that was lesson 1.
Seriously?
That's lesson 1. Yeah.
Are you?
I'm done. All right. So, okay. Let me add this to the form. Wait. So the quadratic form looks like this. So how? Wait. You're gonna ask the question. So generally, you want to write f of x is equal to ax squared plus bx plus c, where a, b, and c are all numbers. And by this, I'm just saying make sure you write the x squared first, then the x, then the number. What question am I asking here?
How do you write a quadratic?
Yeah, but you speak normal, hopefully, when you write. How do you write a quadratic? That's how you write it, in that order. Okay, now I have officially hit everything in lesson 1. I'm sure. I'm looking at my notes. And I guess there is one special thing I'll say here. The special thing is a cannot be 0 because then you'd have a linear. So that's the one key thing to take from that. But I think we can all assume that. All right, on to lesson 2. Lesson 2 is Intro to Factoring Quadratics, and to do that, I need to tell you how to FOIL. So here is the answer to the question you need to think of. This is how you do it. You have, I don't know, let's give x minus 4. We'll do x plus 4. Okay, first. So the first two terms, first and first. X times x is a, shout it out. X squared. So the first and first, and then the outer. So outer, this one is on the outside, this one is on the outside. So these two, when I multiply them, so an x times a positive 4x is a, or sorry, x times a positive 4. Positive 4x. All right, Ben, you do the next one. Inner is going to be what times what?
Negative 4x.
All right, negative 4x. And it's going to be last. L is what?
Negative 16.
Negative 16. Perfect. Simplifying this, that gives you x squared minus 16 because the 4x and negative 4x cancel each other out. What was the question I asked here?
How do you FOIL?
How do you FOIL? Perfect. And I guess FOIL should be in all caps because it's technically an acronym. So I'll change that. F-O-I-L. And this stands for first, outer, inner, last. If you want to add it to your notes, you can. I think it's kind of review at this point. All right, so I needed to define a few things for this chapter, or this lesson 2. So factors are, and again, this is a new question that I'm asking and answering. Factors are, it's the things that you multiply. Things that you multiply. And I'm not just talking about polynomials or quadratics or anything. I'm just, in general, when you talk about math, factors are the things that you multiply. So 2 times 3 is 6. The factors of 2 times 3 equals 6 is 2 and 3. Those are the things we multiplied. So the factors in this case were what and what?
X and 4 and
Close. So the factors of that one were x minus 4 was one of the factors. So that was the first factor. The second factor was x plus 4. Those were the two factors. So I'm going to write 2 there. I'm going to try rewriting that. 2. Those were the factors. Okay. What question was I asking, Ben? Because Claire's done the last 2. What was the question I asked for this part right there?
What are factors?
Perfect. All right, and here's the answer to the next and almost last, I think this is almost the last question. Second to last question is, well, terms, since you asked, are these. So terms are the things that are being added. Usually it refers to an individual component. So the terms in this one were x was being subtracted, well, I guess added or subtracted is, maybe put that in parentheses, or subtracted, or minus. So x was a term, negative 4 was a term, x was a term again, and 4 was a term. All of those were terms. And maybe you want to think of, maybe this is a term. So 4 is a term, and then maybe there's no subtracting. So those were all terms. So x is a term, 4 is a term. Maybe you want to think of this as negative 4. X is a term. It's the individual components. All right, what question was I asking? Pretty straightforward, right? Okay, Okay, I can spell what?
I'm trying to not say every single one.
What are terms? All right, and then last but not least, I need to teach you how to do our simple factoring. Here we go. So now that you have asked, well, this is how you do simple factoring. I'll ask the question. I'm getting kind of tired of doing this. So the question is, how do you do simple factoring? And this is my own definition of simple factoring. Most mathematicians won't agree on what this is. But this one I kind of think of as like pulling out the greatest common divisor. So think of this as pulling out. Or maybe you want to think of this, because Ben did like dividing that one day. So maybe you want to think of this as like dividing out.
GCF.
Yeah, the greatest common factor, GCF. So you pull out the greatest common factor. Let's see a quick example of that. So say you have, oh, no, go away. Say you have some, I don't know, 3x squared minus 6x. I just have a statement here. There's no equal sign. This is not an equation. So this statement, how do I do simple factoring on this statement? This turns into what? What's the greatest common factor of these two terms?
3x.
Yep, 3x. So 3x is going to get pulled out of the statement. So 3x, and then I write my parentheses. What is left over? What do I have to distribute the 3x into in order to get back to 3x squared minus 6x? And Claire, you want to answer this one?
X minus 2.
X minus 2. So now I have two, what do I call these things? They're being multiplied? Yeah, now I have two factors. So after you do simple factoring, you should have factors, because that's the definition of factoring. All right, and that's, yeah, you pull out the greatest common factor, 3x. I can't pull out anything greater, so make sure, I'll leave this with a note until we do our summaries. Our summaries are right after I say this. When you pull out your greatest common factor, that greatest common factor will probably have two components. It will have a number component, and it will have a variable component. Sometimes there are no variables to factor out. Sometimes there are no numbers to factor out. But always think of these two components. Did I factor out all the numbers? Did I factor out all of the variables? Do you guys want to see a harder example, or do you just want to do the summaries into the homework? Good? All right. That ends the lesson. And I don't actually have two worksheets. I have one worksheet where I have half the problems from each of the original worksheets. So it's basically the same length of assignment. All right, yeah, that concludes it. Do you guys want to say bye to Arrow?
Bye.
All right, bye, Arrow.